All right, so today we are going to be doing a lab where we are doing the series, like 6 different chemical reactions. And in those chemical reactions, we're going to observe what's taking place and then try to write balanced equations to represent those. So that's kind of the goal for today. So the first reaction that we're going to do is I need to get a little bit more of my material, which is over here. First reaction we're going to do today is we're going to burn a piece of magnesium. In order to do that, I have to light my burner. This right here is generically called a burner, okay? It's technically called a Tirrell, T-I-R-R-E-L-L burner, but most people just call it a Bunsen burner. Bunsen burner was kind of the primitive version of this. They've kind of made some upgrades to it. But you're connected to the gas, and anytime you have gas, the perpendicular is always off, parallel is always on, okay? With the Tirrell burner, we can control the oxygen down here at the bottom. And so I can put this, I close this down, and I turn this on full blast, parallel right here. And so now no gas is coming out, but I open this up at the bottom, just a little bit, okay? And when I do that, now if I turn this oxygen way down, you see that yellow flame. We don't want that yellow flame. That's not a good flame. That's not a controlled flame. That's not a hot flame. So we always want to open up the oxygen and get a nice interior blue cone. And you should be able to kind of see it right here forming that interior blue cone. That's the hottest part of this flame, okay? So the first reaction that we're going to do is we're just going to take a strip of magnesium metal, okay? Not a big one, just a strip of magnesium metal. These are called crucible tongs. We're just going to hold it in the tongs and put it into the fire. And we're going to see, ooh, it burns super bright, okay? You don't want to really stare at this. It's not good for your eyeballs, but you can see a bright white light being given off, flame. Okay, this is what they use in fireworks for the big white flashes. It just makes a powder. So when magnesium burns, that means when something burns, it's combining with oxygen. So when it combines with the oxygen, it made that white, ashy looking substance, which you can then complete on what the formula would be of that compound. Okay, so the second reaction is taking that same piece of magnesium, okay, and reacting it with some sulfuric acid. So I'm going to put some sulfuric acid into my test tube. It says about a fourth full. It really doesn't quite matter how much we put in there. Okay, so that's going to be enough. So we put that in there. I'm just going to take another small piece of magnesium. Break it off here. I'm going to put that in here. Now we never ever hold a test tube in our hand when we're doing a chemical reaction. You don't know what's going to happen. It's just not good. It could boil over and get acid all over your hands. So we're just going to hold it with this test tube clamp. Okay, so I'm going to put this down into here, and immediately you can see that it begins to bubble and give off a gas. Well, we want to see, is that gas flammable? So we test it. Okay, ooh, it gave a little bit of a pop. Okay, try it again. Okay, you can see that it's catching, that gas is catching on fire. So the gas that's being given off is definitely flammable. Okay, we won't do it again. Okay, now because it's just pure. There's no oxygen down in there anymore. Now, don't want to go out. Now, if I feel the bottom of this test tube, it's super hot. I mean, burn my fingers hot, okay? And that's not from me putting the flame up here. That's from the reaction down here. So this test tube got super hot when the chemical reaction. Notice the magnesium completely disappeared. It dissolved. So you can't see any of the magnesium anymore. So it went completely away, and it bubbled, fizzed, and got hot and made this clear, colorless solution. Okay? So our third reaction, our third reaction is going to be, where's our third reaction? It's going to be take some copper sulfate into a test tube. Then I'm going to take some iron filings. Iron filings is just iron metal that's been, you get shaved off. Notice the color of the iron filings, kind of this brownish kind of color. And I'm going to put those in. I'm going to give another good scoop. Put those in. Okay, and then I'm just kind of going to give it a shake. Now as I let it settle for just a little bit, you can begin to see a reddish orange solid forming on the bottom. Okay, there, let's see if I can get it to where it doesn't move away. There we go. So there's a bunch of red, orange solid forming at the bottom. So again, you're putting iron, metal, into copper sulfate. So what do you think that orange, reddish orange metal is forming at the bottom there? So I'm going to let this just kind of settle out for a little bit, and we'll just kind of look at the solution that was dark blue to start with. And then actually, here's one that from the previous experiment. And so now you can really see the copper, the reddish orange down here at the bottom, and then the blue color has really kind of faded some. It's not nearly as dark as it used to be. Okay? So that was number 3. Our fourth reaction is to take some HCl. Okay, I'm running low, but I think I have enough. Take some HCl. I'm just going to pour some of this into a test tube. Okay, so I have this. And I'm going to add some phenolphthalein to it. Phenolphthalein is what we call an acid-base indicator. It's, in other words, it changes color whether it's in an acid or a base. For this particular one, we just need 1 or 2 drops. And we put that in, and notice that there's really no color change. Phenolphthalein is colorless in an acid. But when I take some NaOH, acids neutralize bases, bases neutralize acids, acid-base neutralization reaction. As I add this, ooh, you can see the magenta color, but it disappears. It's like magic, but it's really just science. Okay? So the OH minuses are searching for the H pluses. When they find them, they go and make water, but now that means I have more H pluses, more OH minuses, so now it's a base. If I take a little more acid, add just a little bit more acid to this, I can make that color disappear. Acid, so now I have a little bit, it's a little bit more acidic than it is basic, so the color went away. We could go back and forth over and over and over again. This is a very reversible reaction. I take my NaOH, and I can make the magenta color come back. So phenolphthalein is acting as an acid-base indicator here as we combine HCl plus NaOH. So you can write a balanced equation for that. You can record your observations. There's no real heat change on that one. Okay? So our fifth reaction is to take another test tube, and we're going to put some manganese dioxide into it, MnO2. MnO2 is this black looking solid. Swing and a miss. I missed with some of it. I'm going to try and get just a little bit more. Okay, I got that in. Okay. Now I'm going to take some hydrogen peroxide. Hydrogen peroxide decomposes. You can even kind of see little bubbles all on the side of this. I don't know, hopefully you can see that there's bubbles. That's the peroxide already decomposing because of the light in this room. But as I put it into here, okay, it begins to fizzle and pop, okay? And then if I take a wooden splint, okay, that's on fire, but I blow it out and I put it down in here, it catches back on fire, okay? It's catching back on fire down here inside this tube, okay? Why do you think that's happening? What happens when the peroxide decomposes? That, if you go back and look in your notes, we talked about that as far as what happens with the peroxide when it decomposes. In this case, the MnO2 is acting like a catalyst. A catalyst speeds up a chemical reaction without changing itself. And so it reacts as a catalyst, and if you recall, you put the catalyst over the arrow in the equation. It's neither a reactant nor a product, it just goes over the arrow. So when you write your balanced equation, you need to include the MnO2 as a catalyst. And then lastly, we take some baking soda, sodium bicarbonate, put it into a test tube, okay? So I have some baking soda. I want to go ahead and let's go big or go home here. This is the last one. Okay. Now, I'm going to take this and I'm going to put some acid into it. I'm out of acid over here, so I'm going to steal some from over here. So here's some acid now on this one. So I'm going to put some acid into this. I don't know if you, hopefully you can see this, but it's bubbling, fizzing, okay? You got all kinds of bubbles. So let's see what happens if I put a wooden splint down into this now, into this one. If I put it down into here, now it goes out, okay? It goes out because the gas that's given off on this one doesn't burn, okay? The splint won't burn in it, okay? And then when I feel the test tube's getting cold. Test tube's getting cold. So we got bubbles, gas given off, test tube got cold in this reaction, okay? So that's your reaction. So you should be able to fill in all the observations. You should be able to write your balanced equations. Now, when you write the balanced equation, you also need to include what state it was in, okay? Was it a solid, or was it all of these here in the bottles that are liquids? They're all aqueous. These are all solutions in water, okay? So they would all be represented as aqueous. And then think about the products, how the products looked in the different reactions, okay? And then once you have that done, then you have those conclusion questions on the back that you need to do. And we're gonna work on writing and balancing and doing our total and net ionic equations. We had that e-learning assignment yesterday. So Monday in class, we're gonna really kind of go over all of that. Tuesday, for e-learning, you're really gonna be focused on just finishing this up here. And then Thursday, we'll probably just kind of go over some things, and then we may end up having a quiz either on Thursday or Friday over equations, okay? So if you have any questions, email me about this lab, but hopefully you saw enough to where you can fill this in and complete it. Wish you were here. It's much better in person. All right, well, have a great weekend and go Jags.